Good morning, everyone, and thank you for inviting me to be here. This is very exciting. And thanks, Jim, and your team for the leadership in the Biomass to Biochar conference. And I also thank my fellow Working Group 1 members who I'll introduce at the end of this presentation. Working Group number 1 focused on place-based biochar, that is producing biochar on site. We're doing this in the context primarily of forest restoration and fuels reduction and converting waste to a resource. And who needs this place-based biochar production? Well, a long list of individuals and organizations: public and private forest landowners, farmers and orchardists, urban foresters and arborists, permaculturists, community educators, and very importantly, habitat restoration contractors. Our group looked at the opportunities and challenges from engineering, economics, and ecological perspective, as well as engagement and education. And what we determined, one result of our analyses were that we recognized the need for an environmentally friendly, ecosystem-informed biochar production system with sustainable outcomes. And to do that, we needed data, designs, and testing for kilns and methodologies for quantifiable, consistent results, and replicable, scalable production on site with these benefits of high production, low emissions, carbon sequestration, compatibility with the landscape, and sustainable outcomes. And we looked at this first from an engineering and ecological perspective, what those perspectives were telling us and helping us to define the parameters of our need. One, of course, we need to be place-based, a scalable flame carbonizing device to pyrolyze, gasify woody crops residue in forest / in the field. We needed simple equipment, no moving parts, relatively low cost, scalable, and again, portable. And we needed to get knowable results from the use of these kiln types. We need to have a design match for the environment, so we can, and in the residues, so we could actually quantify the outputs. We needed to have our carbon sequestration values measurable, and we needed to know what we were emitting when we were operating these kilns. That would allow us to both improve the design, reduce pollution and greenhouse gases, be permit ready, and support industry-wide sustainable best management practices, and to know how to contract and perform. We also included the socioeconomic and ecological benefits that we were driving for. And one is certainly to reduce waste, turn that into a valuable resource, look at air and water quality, and not just meet the requirements for permitting, but actually to show leadership in setting a high standard for emissions and carbon outputs. We wanted to ensure carbon neutrality and be allowable to get carbon credits. We needed the right equipment for the job and the landscape. We needed to have the ability to have clear contract specifications so land managers could specify exactly what they wanted and expect to get it. And we had to have the other elements for a thriving business and job creation, and that is sustainable outcomes, output data, and for creating jobs and profit. So the proposal that grew out of these desires and needs is a fairly straightforward one. One is we wanted to start with identifying and conducting rigorous testing of at least 3 types of state-of-the-art on-site kilns, but have those kilns tested in a variety of scenarios. We were looking at spreading projects out over 200 diverse acres of public and private forest lands, and then we would collect data to quantify the outputs and the cost by design, the biomass type that we were using, the site conditions, Topography, for instance, has a huge impact on how you can operate efficiently and effectively. This can affect how you bid and contract on a per acre basis, and we wanted to get those metrics into a per acre basis format. And we would determine the most efficient kiln design for particular environments, and topographies. Then measure emissions by kiln to determine efficiency, cleanliness, and qualifications for air quality permitting and environmental benefit. Definitely measure that carbon retention by kiln design so we could establish carbon sequestration value and compete in the carbon markets. Conduct a life cycle assessment to establish the metrics necessary to access those offset markets. And that includes the entire life cycle, from fabrication of the kilns to transportation to the actual production. And we would work with landowners to establish the parameters and metrics to monitor the biochar operational impacts on site conditions over time. So to do that, we're looking at a 4-year project. We would have 3 field seasons. In the spring, we would be focusing on kiln design, site prep, and aggregating feedstock and collecting data on that. Then in the fall, we would conduct our burns to produce biochar and test the kilns. Through the winter would be spent in data analyses, adaptations of the project design, and tech transfer. The cost for this project would be just over $500,000, and we would be expecting that our partners would at least be able to match up to $100,000 or more just by their participation, equipment, other things that they could contribute to the project. And this would cover the entire spectrum of the project, and overhead is included in those line items. So with that, that's our proposal in a nutshell. And I want to thank my co-workers in this group, Kelpie Wilson, Dr. Ken Carloni, Kai Hoffman-Kroll, and Carson Springer, all of us actively involved in on-site, place-based biochar production and education. So all of these will be written up in a lot more detail in the upcoming Biomass to Biochar Maximizing Carbon Value publication that Jim was telling us about.